let's finish up 2.2, and then we'll have time for questions. Okay, so in 2.2 we started talking about comparing sets. We talked about this symbol, which means is an element of and is not an element of. And then we did a couple examples with that, right? Then we talked about set equality. We said two sets are equal if they have the exact same elements. Then we did a couple examples. We said order doesn't matter. These have the exact same elements. Then we talked about equivalent sets. We said sets are equivalent if this is true. What does this mean? Good. So this n of A, n of B, this is the cardinal number of A, the number of elements of the set A. And this is n of B. This means the cardinal number or the number of elements of B. And we said determine if the sets are equivalent. So in order to determine if sets are equivalent, we need to see how many elements are in each set. And we did that by simply counting, right? We just counted the number of elements and compared. If they have the same number of elements, I don't care what the elements are, they are equivalent. Here, they didn't have the same number of elements, so they are not equivalent. That's it, right? Equivalent means same number of elements. All right. So we left off with those examples. So now let's do another definition. So we're going to do topic C, which is subsets. So a set A is a subset of the set B, provided every element of A is also an element of B. So we write that A is a subset of B. If not, we write A is not a subset of B. Okay, so that's a definition, so we'll box it in. So A is a subset of B if every element of A is also in B. A is a subset of B. If not, we write the same symbol with a line through it, right? So let's do an example. Determine if the following are subsets. So this is example number 8. So basically I'm going to look at these sets and read the definition over and over and over to myself. Okay? Number 8, we have set A equals 1, 2, 3. Set B is the set 1, 2. So determine if the following are subsets. Is A a subset of B? Is B a subset of A? That's what we're checking. So in order for one set to be a subset of another, they have to have exactly the same elements. So is A a subset of B? Why not, Michael? They don't even have the same number of elements, so how can they have exactly the same elements? They cannot, right? The number of elements, the cardinal number of A is 3. The cardinal number of B is 2. If I have 3 elements, it's not going to be the same as 2 elements, no matter what the elements are. So A is not a subset of B. A is not a subset of B. Is B a subset of A? Quentin says yes. Why do you say that?
They both have 1 and 2.
They both have 1 and 2, so good. and I'm going back and just reading the definition like a broken record, all of the elements of B are also elements of A. 1 is an element of B, also an A. 2 is an element of B, also an A. So B is a subset of A. I kind of think about this symbol like a C, like contained in. B is contained in A. All elements of B are contained in A. So that's what it means to be a subset. All of the elements of B are also elements of A. All right, let's do another example. C equals X such that X equals 2N, where N is in fancy N. Oh gosh, what does that mean? D is the set Y such that Y equals 4N with N in fancy N. Oh gosh, is one of these a subset of the other? Well, we need to go back and make sure we know what the set notation, right? What are these sets? So Meadow says these are the natural numbers. This fancy N is the natural numbers. So let's write out the natural numbers. So sometimes I think it's hard for people to read from this set notation. So let's write it a little bit easier. So I'm going to write, what's my N? Natural numbers, so what are those? The counting numbers, 1, 2, 3, 4, dot, 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 forever and ever, right? Whole numbers, all positive, not including 0. All right, so if I'm trying to figure out what set C is and what set D is, first I'm writing out this, and I'm going to plug these N into where I see the N in order to write out what set C is. So C equals, okay, I plug 1 in here. I have 2 times 1. That equals X. X is in that set. So I have 2. I plug 2 in for N, right? N is in the natural numbers. These are the natural numbers. I'm taking 2 as N. That's 4. Now 3, I'm plugging 3 in for N. 3 times 2 is 6, so 6 is in C. Now I'm going to plug 4 in. 4 in for N. 4 times 2 is 8, so 8 is in C. And then I have dot, 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 so I'm going to continue with dot, dot, dot. All right, let's figure out what D is. Can you guys do D by yourself? So D, I'm going from the natural numbers, right, because N is in the natural numbers, so I'm going from the natural numbers, and I'm plugging into this formula to see what my elements look like. So these are the natural numbers. I plug 1 in. 1 times 4 is 4. 4 is in D. I plug 2 in. 2 times 4 is 8, so 8 is in D. 3 is a natural number. I plug that in. 3 times 4 is 12, so 12 is in D. 4, I'm plugging my natural numbers N into this formula to see what my elements of the set D look like, right? Is that clear? I'm getting 1 yes. That's clear? So I'm going from this set, the natural numbers, and I'm plugging those values in because those are my little n's. I'm plugging those values into here to see what my elements look like. Okay, so now that we wrote it out a little bit more clearly, are all of the elements in one set also in another set? So Meadow's saying D is a subset of C. What do you guys think? Well, let's go back to the definition, like a broken record. Are all of the elements of D also in C? Yes, right? 4 is an element of D, it's also in C. 8 is an element of D, it's also in C. 12 is an element of D, it's part of the dot, 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 but it's in there, right? Good. Is C a subset of D? No, why not? Tell me one element in C that is not in D. 2. 2, 6, right? 2 is an element of C that's not in D, so C is not a subset of D, but D is a subset of C. Good. All of the elements of one set are also in the other set. Before, too, with number 8, somebody said, well, this is size 3, this is size 2, so there's no way A can be a subset of B, right? What is the size? What's the cardinality? What's the cardinal number of C? How many elements are in C? Infinity. How many elements are in D? Infinity. So I can't always use that, right? They're both infinity, but we can't really tell. Okay, so this is my answer. All right. Do you guys want another example? Yeah? Okay, number 10. A equals the set X such that X equals 2n plus 1, where n is in n, and B equals the set of Y such that Y equals 2z minus 1 for z in fancy Z. All right, so what do you guys think?
I have a question.
Yes.
When you draw that symbol, are you drawing like a circle with a C through it?
This?
Yeah.
I'm drawing like a C and then a line. So C and then line. Does that make sense? Is it too small to see?
I just couldn't, like when you did it before, I couldn't tell what the symbol like actually looked like. I was just
C, line. Yeah, it's a little small. All right. So, can you guys tell if one set is a subset of the other? Does anybody have a guess? Seems like everyone's kind of staring at it a little funny. So let's try to do what we did in the previous example and write out the set a little bit more so it's less tricky. Okay, so for A, what's my base set I'm going from is the natural numbers, right? N is in the natural numbers. So I need to, let's write out the natural numbers to see if I can see what that, plug those in and see what I get. Okay, so these are the natural numbers, which makes set A equal. All right, I'm not starting with dot, dot, dot in the natural number, so I'm not starting with dot, dot, dot in my set A, right? I'm going to plug 1 in. 1 times 2 is 2, plus 1 is 3. I'm going to plug my next one in. 2 times 2 is 4, plus 1 is 5. Another natural number, another value of n is 3. 3 times 2 is 6, plus 1 is 7. What's my next number? 9. What's after that? 11, dot, dot, dot. So Nick, you see the, or sorry, so Luke, you see the pattern, right? It's the odds above 3, right? So that, sometimes that's easier for people to look at, right? Okay, let's now go to set B. Set B, I'm starting from Z. What is Z again? What is it? The integers. So somebody help me write out what the integers are. What is it? You have to have the dot, dot, dot. Yeah. -3, -2. Three, dot, dot, dot. Okay, so now if I'm looking at B, I need to start with the dot, dot, dot. I'm plugging in the dot, 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 right? B equals dot, dot, dot. Now plug in -3. What do you get? -3 times 2 is -6, minus 1 is -7. Plug in -2. -2 times 2 is -4, minus 1 is -5. -1, plug -1 in. 2 times -1 is -2, minus 1 is -3. 0 times 2 is 0, -1. Plug 1 in, I get 2 times 1 is 2, minus 1 is 1. Then what's next? 3, 5, 7. Dot, 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 right? Okay, so now we can kind of see A a little easier if you don't like that set builder notation, and we can see B. So is one a subset of the other? Yes? No? Maybe. What's the size of A? What's the size of B? They're both infinity, so I can't look at the size and use that, right? Okay, so what do you guys think? Are all of the elements of one set also in the other set? Yes. Okay, what? A is a subset of B. What do you think? All of the elements of A are also in B. Is that true? 3, that's in there. 5, that's in there. 7, 9, 11, right? Yep. So A is a subset of B. Good. All right, let's do one more.
Are you using a lesser or equal to set?
Again, that's like a C.
Oh, okay.
Sorry. I'll make it a little more of a C. It's almost like the less than or equal to, but it's a C with the line under it. Thank you, Meadow. Probably helped everyone. My terrible penmanship. All right, let's do another example. I'm going to write a bunch of sets, and you're going to try to figure out some of the things we've already talked about. Does anybody see one set being a subset of another set? Everybody look, you should be able to find at least one set that is a subset of another set. So look, look, look. All of the elements of one set are also in the other set. What do you guys think? Carlos, what do you think? All right, who can help Carlos? All right, who wants to try? Okay, so A is a subset of B, and you're saying B is also a subset of A. So all of the elements of A are also in B. 3 is an element of B that's also in A. Yep. 1 is an element of B that's also in A. Yep. 2 is an element of B that's also in A. Yep. So A is a subset of B, B is a subset of A. Very good. Not only, so if one set is if two sets are subsets of each other, what do you guys think that means? A equals B. If you have both, if you have one's a subset of the other, back and forth, then they must be equal. All of the elements from here are in here. All of the elements from here are in here. They must have the exact same elements then, right? Would D be a subset of C? What do you guys think? I see a bunch of people saying yes. All of the elements of D are also in C. So 4 is in D, also in C. 1 is in D, also in C. Yep. So D is a subset of C. Very good. So we said these are our subsets. We said A and B are equal. Can you tell me anything about equivalent? Are any of the sets equivalent? What? Yeah, so the definition for equivalent was they have the same number of elements, right? So A has 3, B has 3, C has 3. So A, B, and C are equivalent. Equivalent or in one-to-one correspondence. Good. No, it's okay. Hope everything's all right. Okay, so the set A is a proper subset of the set B provided A is a subset of B and A does not equal B. So we're defining proper subset. Okay? Example. So if we want to figure out if two sets are proper subsets, we need to check these two things. Okay? So determine if the following are proper subsets. Okay, so this is example 12. A equals 1, 2, 3. B equals 1, 2. And C equals 3, 2, 1. Solution. So what do you guys think? We already talked about these three sets with just being subsets, right? One of them is a subset of the other, right? So now we need to see if they're subsets and if they're not equal, right? What do you guys think? So what does it mean to be equal sets? They have the exact same elements. The exact same elements. Order does not matter. Right? A, so let's write out all of the subsets, then we can find proper subsets. Okay, so we said A is a subset of B, B is a subset of A, B is a A is a subset of C, A is a subset of C. All of the elements of A are also elements of B. All of the elements of C are also in A. B is a subset. All of the elements of B are also in A. And all of the elements of B are also in C. So those are all of my subsets, right? So now I've written out all the subsets. Let's see if any of the sets are equal. If they are, then they're not proper subsets. So are any of the sets equal? A and C are equal, good. So they're not proper subsets of each other, right? So B is a proper subset of A, and B is a proper subset of C. Because B and A are not equal, and B and C are not equal. So those are proper subsets because they're not equal. Okay? Good?
You know how you did like the A and the C and then the C to the A? Why can't you just write like one of them? Because isn't it the same thing?
It's not the same thing.
Kinda-ish.
No.
Okay.
Just like I can't write B as a subset of A and A as a subset of B. That's not true, right?
Okay, yeah, makes sense.
Okay. Michael, you had a question?
Why didn't you put the line under like the C in the second C?
Because that's this. Oh, sorry. That's part of this we've written. So A is a proper subset of B. Thank you. I forgot that part. So that's how you show proper subset. That's the symbol for it. Thank you, Michael. It's a lot of definitions. It's a lot of symbols. All right, let's do another topic. Venn diagrams. So Venn diagrams, we usually represent, it's usually for set, talking about sets, we usually represent the universal set as U. What's the universal set again? So the universal set is all elements being considered. It's any possible element. And then we make sets as circles. A. Here's a set D. Here's a set B. Here's a set C. So that's just an example of what a Venn diagram looks like. Again, the big box is U, or the universal set. All elements being considered, and then you have other sets, and they can have different kinds of overlap, different kinds of circles, different kinds of... Okay, so let's do an example. Draw the following. As a Venn diagram. Oh, bless you. Okay, this is number 13. Set equality. A equals B. So tell me the definition for set equality again. That's equivalent. U is the universal set. It's like all elements being considered. So usually that universal set is represented as a big box. All right, if I have this as set A, how do I draw set B so that they're equivalent? Set A equals set B. Would they be next to it?
I mean, like, it's the same line, right? They're equal.
Yeah, exactly.
Put the B next to the A. Like,
Oh, write the letters next to each other. Oh, I see. Yeah, that's a good idea. I'm going to try to write it as, draw it as a different color, just right on top of each other. So this can be set A and set B. Good. So I just tried to do it in different colors so we can see. So set equivalent. So let's point to it and read the definition. This element is in A. Is it also in B? Yes. This element is in A. It's also in B? Yes. This element is in B. Is it also in A? Yes. So they have the exact same elements. They're equal. Does that make sense? So I think it's really important for this section to know the definition, because everything I'm going back to, I'm just repeating the definition like a broken record, right? All right, let's draw another one. A is a subset of B. So how do I draw that? Again, this is my universal set. All right, I have, let's do this set B. So if A is a subset of B, what's the definition of that? All of the elements of A are also elements of B. So where would I draw that? A circle inside of B. What do you guys think? All elements of A are also in B. This element in A is also in B. Yep. This element in A is also in B. Yep. So I agree.
I have a question. So you, for 13, like, that was a test. I can put A and B next to each other and go just one circle to the minor.
Yeah. All right. So we're going to do more with Venn diagrams in 2.3, but it's good to get to know what a Venn diagram is. All right, 15. Find all subsets of the following. So we're trying to look at a set and find all possible subsets. Okay, say A equals smiley face, sad face. I don't care what my elements are. I have a 2-element set. I need to find all of the possible subsets. So something important is that you need to have the whole set and the empty set as your possible subsets. The empty set is the 0 with a line through it, or the squiggly brackets with nothing in it, right? And you also need to have the whole set. Right? We saw in a previous example that 1, 2, 3 is a subset of the set 1, 2, 3, right? Okay, what are the other possible subsets of this set? Just the smiley face and just the sad face. So are all elements of this set also in this set? Yes. All elements of this set are also in this set? Yes. So these are subsets. Good. Can you guys think of any other? Huh? So sad face and smiley face are equal sets, right? Right? 1, 2, 3 and 3, 2, 1 are equal sets, so we don't need to write those down twice. So these are all possible subsets. Okay, let's do another one. So this is a set with 2 elements, has 4 subsets. All right, next let's do B equals 1, 2, 3. So it's just a 3-element set. I could have chose happy face, sad face, I don't know, something else, right? But I chose 1, 2, 3 because it's easier to write. All right, so to find all the possible subsets, first we have to start with the empty set and the whole set. And now somebody tell me some subsets. Are there any 1-element sets that are subsets? Yeah? What are they? The set 1, the set 2, the set 3. Good. So all of those sets, right, in order to be a set, you have to have the squiggly brackets. All right. Are there any 2-element sets?
Yeah.
What?
1, 2, 1, 3, 2, 3.
Are there any 3-element sets? Yeah, but we already wrote it. Are there any other 2-element sets? No, so I think we're good. 1, 2, 3, 4, 5, 6, 7, 8 subsets. So any set with 3 elements is going to have 8 possible subsets. People's biggest mistake is they forget the empty set and the whole set. So that's always the first thing I write out because it's easy to remember. All right, C, let's do a 4-element set. Let's say A, B, C, D. All right, write out all the subsets. You guys do it.
How does the whole set of subset? Isn't that equal?
It's equal, but all right, in this one, if you go to the definition, all elements of this set are also in this set. That's the definition. We're not talking about proper subsets. We're just talking about subsets.
So then how is the empty one equal then? Because it has none of the same number, it's empty.
So this is the set of nothing. Nothing is also in there. I just can't write like an empty space with a comma. The empty set is always a subset of every set. All right, so try to write them all down. The thing that's important is to try to do it in a systematic way, right? First, list all one-element sets, then list all two-element sets, then list all three-element sets.
Would the empty set count as a subset? Is that why there were 8 in the last one?
Yes.
Okay.
All right, what'd you guys get? Who can tell me some one-element sets? Jalen, what you got?
Just A by itself. What do you need some more?
Yep.
All right, B. C. And then D.
And then D. All right, who can tell me some two-element sets?
A, B.
So make sure you start and end with the squiggles, and you have a comma in between. Emily, you want to help?
C, D, and then AD,
B, D,
and then AD.
A, D.
B, C.
Yeah,
B, C. Okay. Is that all?
Yeah.
I don't know. I'm asking you guys. AB?
Oh, sorry.
So what I usually do is I go A, AB, AD, AC, AD, and then I move to B, BC, BD, and then I move to C and I go CD. So I try to do it in a systematic way because you guys got them all, but sometimes if you don't do it in a systematic way, it's a little bit easier to forget something. So I'm just going to erase it and write it in a different order because I think that that's what works for me. If this works for you, though, perfect. It's definitely right. But again, I like to go to the first element and match it up with each of the other elements. A with B, A with C, A with D. Again, I start and end with the squiggly brackets, and each element is separated by a comma. Okay, so those are all the possible two-set elements with A in it, right? Okay, now let's go to all possible two-set elements with B in it. Well, BA I already wrote. So now I go BC, BD. Are there any other two-element sets with B in it? No. Okay, write all the two-element sets with C in it. CA I already have. CB I already have, so it's only CD. So there's 6 of those, right? So let's write out what we're doing. Here we did the empty set and the whole set. Here, this is one-element sets. Here, this is two-element sets. And now what do we need to do? 3-element sets. Okay, so everybody try to write that out. So again, I like to do it in a systematic way. A, B, and then I'm going to change the last element. A, B, C, A, B, D. Okay, now I'm going to change that second element, A, C. A, C, B, I already wrote that, right? A, C, D. All right, now I'm going to change the third element, AD. If I write AD, then I have ADB, already have that. ADC, already have that. So I changed the second element as much as I could. Change the third element as much as I could, right? So now let's change the second element. So I have B, C, D. Is that good? I think that's it, right? Yeah. So let's count them out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. All right, so 16 subsets. All right, so let's summarize a little bit. So my two element set had 4 possible subsets. My 3 element set had 8 possible subsets. My 4 element set had 16 possible subsets. What's my 5 element set going to have? 32, 25, 20. What do you guys think? How did I get from 4 to 8? Doubled. How did I get from 8 to 16? Doubled. Okay. So I'm multiplying it by 2 each time, right? So we got to come up with a formula. So 4 is 2 to the what power? To the second. How does that relate to my set? So 4 is 2 squared. There's 2 elements of the set, okay? 8 is 2 to the what power? 3. And there's 3 elements of my set. 16 is 2 to the 4th, and there's 4 elements of my set. So I think we have a formula, right? Okay, so the number of subsets of a set A is 2 to the number of elements of the set. How can I say the number of elements of the set? What is it? How do I know the number of elements of my set? Which is what? N of A, right? That's the cardinal number of A. That's the number of elements of my set. Really good. You guys figure that one out on your own, right? What?
Would it not be it's being squared?
So I'm multiplying it by 2 every time, right? So that's 2 to a power. So you guys figure that one out on your own, right? So I think half of the battle with math is, 1, spending enough time practicing, and the other half is recognizing patterns. Right? That's why even with section 7.1, when we talked about solving linear equations, we said, okay, first we do this, and then we do this, and then we do this. That's recognizing the pattern so that you can do anything. Here you recognized a pattern, which means I could ask you, if you have a set with 10 elements, how many possible subsets are there? 2 to the 10th, whatever that is, right? Okay. So now we're finished with this section. We're finished with 2.2. 2.2